Today I'm going to be discussing with you Chapter 5, Sections 5.1 through 5.3. Chapter 5 is probability distributions. We're first going to discuss definitions we've heard before, which refer to discrete and continuous. And we covered these back in Module 1. And just kind of as a review, discrete means they're separated. It means you have integer values, something like number of oil spills off the Alaskan coast. You can't have half of an oil spill, either you have one or you don't. Continuous deals with swing, like swing of a gas gauge or a pH scale, where you can have 7, 7.1, 7.2, and so on. So those are two basic definitions that we need. We also need to discuss the requirements for probability distribution. And the requirements for the probability distribution are on page 221. The sum of the probabilities must be exactly 1, and all probabilities in this distribution should be between 0 and 1. Can't have over 1, can't have less than 0. Probability distributions can also have the mean, standard deviation, and the variance calculated by the use of the formulas on page 222. Most of those involve adding an extra column to your probability distribution table. Probability distributions also have the same requirements for usual and unusual values. And again, they're based off of Chebyshev's theorem, and these are on page 225. The maximum usual value is your mean plus your 2 standard deviations. Your minimum usual value is your mu minus 2 standard deviations. And you can use that to determine if a value is usual or unusual. We also have expected value. An expected value is calculated the same as the mean, except it's used when money is involved. So, for instance, looking at the expected value of a life insurance policy. Will the insurance company who wrote the policy make money over time, or will they lose money? Same thing with games of chance. Games of chance can have an expected value. Are you going to win or lose over time? And that's over time. So in one particular game, it's all the games put together. So it kind of gives you an idea of what should happen over time. Next, we're going to look at the binomial distribution. This is our first discrete distribution. The binomial distribution is used more than any other. It has the requirements on page 233 of a fixed number of trials. Each trial must be independent. They must be categorized into only 2 categories, and the probability of success should be the same in all the trials. Next, you can use the binomial formula on page 235 to calculate your binomials. Some can also be calculated using the tables in the back cover of your textbook. However, most of the time, they can simply be done by hand rather quickly and easily with the use of our calculators today. That covers Chapter 5, Sections 5.1 through 5.3. Hopefully, if you haven't done so, you're beginning to start work in Chapter 5.